Let's get into question 4 from the Edexcel 2023 A-Level Maths paper. This is day 4 for my new daily series where I'm going over one question per day from the paper to help you with your revision. And if you stick around to the end, I'm going to add a bonus question to really help you maximize that revision and get the top grades. Now, today's question is a pretty simple one. The examiner's report said that it was accessible to many students. However, a lot of students still made really silly errors that cost them valuable marks in the exam where they should have got them. I found the 3 main places where you could be slipping up, so let's make sure you get the full grade. Let's go. Okay, so this question says that we've got a curve f of x. It gives us f dash x. It tells us that at the stationary point x is actually alpha, and it says alpha is small. And here in the main part of the question it says use the small angle approximation for cos x to estimate the value of alpha. So they're literally telling you what to do here. You just have to open the formula book and look for the approximation. So when alpha is small, we know that cos x can actually be written as 1 minus a half x squared. So it really simplifies our calculation, especially if we're not using a calculator. Although this doesn't mean you can't use a calculator. So let's have a look at this then. Well, if we know at x equals alpha, it's a stationary point, and at that stationary point, we know then f dash alpha should equal 0. Okay, so f dash alpha is going to be equal to 2 alpha plus a half, and we're going to replace cos x with 1 minus a half alpha squared. So I'm replacing the x with alpha, and we're replacing the cos x with this. Okay, now one thing that the examiner report noted that students did is actually wrote that alpha was 0. It says alpha is small and it says small angle approximation. Don't make the silly error of not reading the question properly and actually really hearing what they're trying to tell you. Okay, the next biggest mistake is not expanding these brackets properly, and that is probably just because you are rushing in the exam. So this should be 2 alpha plus a half times 1 is a half, and then a half times negative a half is negative a quarter. So it should be negative a quarter alpha squared. Okay, and we're going to set that equal to 0 because we're at a stationary point. Now, this looks a bit horrible, but it is a quadratic. We've got a squared term and a non-squared term and our constant. So I'm going to multiply everything by 4. So we get 8 alpha plus 4 divided by 2 is 2 minus alpha squared equals 0. I'm going to multiply everything by minus 1. That gives us positive alpha squared plus 8 alpha plus 2 equals 0. And now this is the point where you really need to pay attention to the fact that it says solutions relying entirely on calculator technology are not acceptable. I think what they're getting at here is you can't use the calculator to do the whole thing, but I wouldn't put it past them that they meant you're meant to use the quadratic formula here. So I would just be careful if they say anything about a calculator, just write the quadratic formula out, even if you use your calculator. They don't know. But let's have a look. So this is a normal quadratic where A is 1, B is 8, and C is 2. And I know this is boring, but we're going to have to write it into the quadratic formula. So it's minus the B term plus or minus the square root of B squared. So that's 8 squared minus 4 times A times C all over 2 times 1. Now, you can type that into your calculator twice to get the answers, or you can just solve it on the calculator. They're not going to know you've written the workings. And then we get 2 solutions. So the 2 solutions we get from that are negative 0.243 and 8.243. So we get 2 solutions. Now here, it says the value of alpha. That's telling us it just wants one value. So you need to realize here that because alpha is small, this is the value that this approximation will work for, and not this one. So we reject this one. So make it clear that we're rejecting this, and this is our solution, okay? This is the one you would write right at the end. So even if you want to make it really clear. Okay, and then let's take a look at part B. So part B tells us that the point P, which is 0, 3, lies on C, and it wants us to find the equation of the tangent to the curve at point P, giving your answer in the form y equals mx plus c, where m and c are constants to be found. Now, this is a pretty easy question. You just have to realize that the tangent has the same gradient as the curve at that point, okay? So we need to use what they've already given us, which are f dash x, and we say, okay, f dash 0. So we want to find the gradient where x is 0. So we put 0 in there. So 2 times 0 is 0, plus a half times, and then cos of 0 is 1. So this is a half times 1, which is a half. So we know that the gradient of the tangent is a half. So that's our m in y equals mx plus c. And you can clearly see here, if this point lies on C, then this must be our y-intercept, because 0 anything will be our y-intercept. So you can just put this straight into the equation, y equals a half x plus 3. Now that is the quickest 2 marks you can ever get. As long as you understand that the derivative gives you the gradient of the tangent, then you can do this pretty easily. Now, you'd be surprised at where people lost marks for this. It's where... My dog has just come to say hello. Are you going to do a bit of maths for this? So, the problem, what was I just saying? So, the place where people lost a lot of marks was this question here. They actually didn't write it as this. They wrote half x plus 3 without the y equals. They want the equation. And so that's what you need to write. If you're watching along, you're nodding, you're thinking, yes, I understand this, but in the back of your mind, you know that you get into the exam and you still lose marks you know you should be getting. That's exactly why I created my A-level maths study club. In the study club, we only look at exam questions. So we are purely focused on preparing you to get exam ready. If you're interested in joining our study club, have a look at the link in the description. I'd love to see you there. So let's have a look at this bonus question. So here it is. Find f of x and state whether it's convex or concave at the point P. So we have been given f dash x and we now need to find f of x. So if you want to go from f dash x to f of x, you need to integrate, because to get to this from f of x, we differentiated. So to get back, we need to integrate. So it adds a little bit of a layer of complexity here. So to get out of f of x, we'll integrate this. So it will be 2x squared. So you add 1 to the power and divide by the new power. So that becomes just x squared. Plus, now cos, this is where some people get tripped up with the signs. A little trick that you can use to remember which way round it is something called cuscus. I was told this by a teacher I used to work with. Minus is on the end, so cuscus, CSCS. Just remember that sine differentiates to cos. If you remember that, you know that this way is differentiate. So the other way must be integrating. So if we're going from cos and we want to integrate cos, we want to go up. From that cos and I want to integrate, I get to sine. Now that one's a pretty simple one, but you could be having one where it was negative cos or negative sine. So just use this as a little tool to help you. So we know we said it just goes to a half sine x. There's no complicated function inside of the x, so it's just this, and then plus c. Now we need to figure out our plus c. So we do know a point on this curve. We know 0, 3. So we know 0, 3 is going to go into this. So the whole function is going to equal 3 when x is 0. So if we put 0 into x squared, that becomes 0. Sine of 0 is also 0. So this just becomes 0 plus c. So 3 is just our c. You might have figured that out just by looking at this, but that's the formal way of doing it. So our f of x function is x squared plus a half sine x plus 3. Okay, so we've done part of that. Now we need to state whether it's convex or concave. So concave looks like this. It looks like a cave. Convex looks the other way. Now, what you have to think is what's happening to the gradient here. If the gradient over here, over this sort of hump, is going from positive to negative, so the gradient is decreasing. The thing that measures how the gradient is changing is the second derivative. So if the gradient is decreasing, the second derivative is less than 0. Here, the gradient is going from negative to positive, so it's actually increasing. So the rate of change of the gradient is positive because it's increasing. Okay, you just have to remember concave is less than 0 for the second derivative and convex is more than 0. So all you have to do is put your x value in and see what it comes out as. So in order to do that, you actually need to find the second derivative first. So we're going to differentiate the first derivative. So 2x becomes 2. And cos, so let's have a look at what cos differentiates to. It differentiates to minus sine. So this now becomes minus a half sine x. Okay, and at this point, we are going to put in 0. So this becomes 2 minus a half times 0 is 0. So 0, so it just becomes 2, which is greater than 0. So we can say that since the second derivative is greater than 0, then the function is, and we said greater than 0 is this one, so it's convex at P, because P was 0, 3. And that's it, that's done. So well done if you already knew that and you could apply that. That is quite a difficult question. It's a bit more of an advanced topic and understanding. Tomorrow we're tackling a question that is a twist on the trapezium, or when it's ready, it'll be around this video somewhere. But if it's not ready, do subscribe so you catch the video tomorrow.